The Transformative Vertical Flight Working Group, Public Services. This is meeting number 91. Today is Thursday, October 24th, 2024. Today we have a very interesting guest speaker, Erika Holtz. She's the Engineering and Quality Manager at Harbour Air. Her topic will be pioneering electric seaplane aviation, the Harbour Air Case Study. So I'm sure that we're all going to be very interested in listening to what she has to say. Before I get into a little more detailed introduction of Erika, let's get to our regular housekeeping matters. Coming meetings and conferences. We have a Electric and Hybrid Aerospace Technology Symposium taking place next week in Frankfurt, Germany. And I will be talking about autonomy for eVTOL AAM parabolic missions. So anybody who's going to attend that, please look me up. Let's have a little chat during the conference or right after. There's also another interesting one scheduled for, well, it's around right-hand side. It's the European Rotors. It's going to take place in Amsterdam. It will be November 4 to 7. Should be a pretty significant event right there. And also across the pond, big pond, is the 10th Asian Australian Rotorcraft Forum. It's going to take place in Melbourne, Australia. That's going to be November 7th to 8th. And an interesting one with the Vertical Flight Society support. It's called the HELMOTXX. Actually, what it is a helicopter military operations technology meeting. It's going to take place in December 4th to 5th. In Hampton, Virginia. And following that, same also in December, anybody in the Asian Pacific area, it's going to be the second international conference on advanced air mobility systems. It's going to be in Singapore, December 4th to 6th. Now, coming up to early next year, just a little forecast, so we have time to plan our trips and so on. The CES, Consumer Electronics show, is going to be in Vegas, as usual, January 7th to 10th. Even though I'm not sure how many electric airplanes going to be there, but I'm going to be there because there's a lot of underground technology, not underground technology. There's a lot of technology embedded in that show that's probably relevant to what we talk about here. Also, there's a AIAA SciTech, again, January 6th to 10th in Orlando, Florida. And the next one will be in Huntsville, Alabama, Sweet Home, Alabama. And it's going to be it's the 2025 Handling Quality Technical Meeting, again organized by Vertical Flight Society in Huntsville, January 22nd, 23rd. So those are some of the forthcoming meetings. If I miss any important one, please feel free to let me know. And with that, I'm going to get back to a little introduction to our guest speaker and the topic. Her presentation will cover the initial concept and first flight to overall program development, why Harbour Air sees a business case for fully electric flight for their operations, and other potential use cases. And you may wonder, say, this is a transformative vertical flight working group. But in reality, for the last couple of years, we have expanded our coverage to including any transformative flight concept platform systems operations, including short field takeoff landing and electric conventional takeoff landing. And obviously, Harbour Air, as you will see, fit right into our interest. Erika has been involved in aviation all her life, particularly in Part 23 aircraft aftermarket repair and modifications sector, as well as developing aviation quality management system, which is very, very needed in the whole transformative aviation industry. Achieving her delegation status in 2010, which is very unusual for somebody, I would say, relatively young age to be able to achieve that as a structured delegate under the Design Approval Representative Program with Transport Canada. And Erika became the one of only 10 structured DARs in the Pacific region and started her own engineering company. I have to say, that's pretty impressive if I were to offer that opinion. Erika has over 20 years experience with modifications to generate general aircraft and over 15 years managing quality systems. Tough job. I had been to a senior VP covering quality systems. I know how challenging that is. Currently, Erika is the project manager and lead engineer for the Harbour Air electrification of the DHC-2, the Beaver project. And with that, I'm going to unshare and let Erika take over the presentation and the talk. Oh, how do I unshare?
I can't take it from you. It won't let me.
I'm trying to unshare. Looking for the command that will allow me to unshare. That's interesting. My toolbar still says share. Hold on. Hey, Tom, my share is paused. So stop share. There you go. How about that? You should be able to share now.
Yep. Is it working?
Can everybody see her presentation?
Oh.
Yes.
Hold on. Am I sharing the right screen? Let me share the right screen.
Okay.
That one. All right.
All right. Thank you. The floor is yours.
Thank you very much. And thank you for the introduction, Johnny. That's very kind. I did give a speech to the Vertical Flight Society at the Electric Aircraft Symposium right prior to Oshkosh. And that's why I was trying to fix up my slides a bit to add in some new content for anybody who'd actually participated in that. So at least I have some new content. So hopefully there's some interesting stuff here for you. So yes, we've been working on the Harbour Air fully electric Beaver project now since 2019. And I'll give you guys a little bit of an overview. So I think it's interesting to start off with who we are and why we're doing this. It goes to the commercialization, although I'll talk a bit more about the commercialization later. How we got here, the proof of concept, how we got to first flight, what we've been doing with the aircraft to date, lessons learned, and what's next. I'm really going to try and leave some time, though, for questions, because it's always more interesting to me to hear what you want to know, not just expound on the things that I like to talk about.
Does everybody have those boxes blocked out on the thing, or is that just my screen?
Yeah, I see it too.
Yes, I have it.
Oh, this thing up here?
Right.
Yeah, and then there's one on the right side.
This one here?
Yep.
Better?
Yes.
Perfect.
There we go. All right. Carrying on then. So, a bit about who is Harbour Air. So we're one of the largest seaplane operators in the Americas. These numbers are a little reduced since COVID. It was a bit higher pre-COVID, but we operate about 280 flights a day, moving 400,000 passengers along the south coast of British Columbia. We operate 45 aircraft. They're all seaplanes. At this point, we are doing a wheeled operation for this winter as a trial run on one of our Twin Otters because of weather operations. But we've been in business for over 40 years now. I'll share with you our route map here. We like to say that we've been doing urban air mobility since before urban air mobility was a term. We've been doing it for about 40 years on this coast. So as you can see, our primary bases here are the Victoria, Vancouver, and Richmond. And the majority of these routes are about 30 minutes, and it's usually done at a fairly average low altitude of about 1,000 foot, because we're just crossing between Vancouver Island and the mainland, connecting the small coastal communities of British Columbia. So we actually consider ourselves a pretty good gateway airline for the introduction of fully electric flight, because our energy requirements are quite low, given the short missions and the low altitude. We also at Harbour Air have a pretty unique opportunity here because we're an air operator who's been operating these aircraft for 40 years. We understand these aircraft very well. We understand the operational environments. We literally have decades of knowledge on the aircraft type, both flying them and maintaining them. But we also, apart from the air operator certificate, we have our aerospace division, which has an AMO that's been around since the late 80s, a manufacturing department that's been around since the early 2000s, and we're working on our design approval organization. We've had engineering expertise in-house through me and my team. We're going to formalize it into a design approval organization. So one of the things that was very interesting dealing with magniX back in 2019 was the comment that they could come up with an engineering concept in the morning, and by end of day, there'd be a part sitting on their desk for them to install or try out. And that's not something you're always going to have access to. Usually you're either an operator, you're a maintainer, or you're an OEM. And we're combining a lot of those skills together, which has given us a very unique opportunity where we are. So this is the Harbour Air eBeaver. I'm assuming people are fairly familiar with the Beaver itself. It's a 6-seat aircraft, single pilot, has 450 horsepower, and the baseline aircraft is 5,600 pounds gross weight. Our premise on this was to remove only the systems necessary to achieve fully electric flight and only change anything that was required to make that happen. We wanted to limit the modifications to de-risk the flight testing and path to certification as much as possible. So what you'll see here on the aircraft, externally, the only changes are the pointy nose, and they made us put the ventral fin on. That's not a new mod. It's one that has been accepted in the past for a lot of seaplane operations. We're hoping to still test to eliminate that, but externally, very little on this aircraft has changed. We didn't change the gross weight of the aircraft, and we did not change the power of the engine. But one interesting benefit we had, you'll see in the performance numbers later, is by putting on the pointier nose, reducing the parasitic and cooling drag, and putting on a more efficient propeller, we had some significant gains in performance that translated to, even though the power was the same, the thrust improved by about 300 pounds, which was pretty interesting. We get this question a lot. Why the Beaver? You know, there are lots of reasons why it wouldn't work, right? It's an older design. It's using older, heavier materials. A lot of the projects these days are looking at using, of course, composites. They're lighter, they're the slipperier surfaces. This is all, you know, bumpy rivets design. It flies fundamentally. I mean, we've had it described as flying like a snowplow through the air. But for all of those reasons, we could actually turn all those cons into pros with this aircraft. It's got over 70 years of service history. We know this airframe. One of the reasons I like to show this picture, there was an even better one that had an ATV, but I couldn't get a copy of it because it was copyrighted. But these aircraft for 29 years operated on an exemption where they could pretty much fly anything you wanted strapped to the floats. Why? Because they could handle it. It didn't bother the airframe. So we have a very stable aircraft that we can test and ensure, and this led definitely into our risk mitigations, is we knew that no matter what went wrong with the powertrain, we could shut it off, we could glide, we could land. And that feeds into a lot of our risk. It's a stable airframe, but there's also, because it flies like a snowplow, there was a significant opportunity for performance improvements, which made it from the very first flight where we said, well, this is proof of concept and engineering, that's very cool, but it's not going to get to commercialization. The performance improvement led to the potential for commercialization. The other thing that I think was really important was the ocean is our runway. Float plane, yes, definitely a lot more drag, but from a system safety analysis perspective, that I think was the single most factor that tipped us over into the scale to getting our flight permit with Transport Canada, because no matter what, we could glide and land, no matter what direction we were heading or where we were in the phase of flight, we could land and get the pilot out safely without impacting any people or structure. So our risk approach was pretty much that. It was very interesting trying to get to first flight. I note the lack of history. It's more, this is something that usually OEMs take on. It's not something a small company or an airline would typically take on. So you don't have, with me being in the aftermarket Part 23 world, we didn't have a lot of pedigree when it came to developing something of this nature. We've done, I mean, I'm a structural delegate. I do aerodynamics, but I've never done electrical systems. And at the time in 2018, when we were told that we were doing this, we were not allowed to hire anybody at Harbour Air that had that kind of background. We had to make do with the team that we had. So a lot of that work actually got pushed off onto magniX to make sure that the power electronics and electrical engineering side of it was taken care of. But fundamentally, we were installing software and airborne electronic hardware components that have no certification and did not have complete system safety analysis or functional hazard analysis. So our very first meeting with Transport Canada, 21 specialists in the room, nobody with any experience with this type of modification or this product. And we went around the room and everybody talked about what they thought could possibly go wrong. We created a very restrictive flight envelope, put very significant limitations on the aircraft. So because we hadn't done any testing, for example, to DO 160, there was very little environmental testing done. We're not allowed to fly into rain, sand, dust, smoke. We were restricted on wind limitations to ensure that we would be able to land on the water, because if it was higher wind, wave action, we might not be able to land. So we had a restricted wind envelope. But what that meant was, as a seaplane operator, it completely reduced the risk. Almost every single page of our hazard analysis that we put together, a list of all the things that could go wrong, ended up in turn it off, glide, and land. And that's, I think, is one of the reasons, as I said, that we were able to get to the flight permit. The other thing I'll show you in a second is our ground testing. We could do simulations. Since then, since we've flown a number of times now with Transport Canada, we closed the certification program. That was a bit of a complication in Transport Canada, that they kept trying to get us to do validation work where we were really doing experimental work. We've been building that relationship with Transport Canada so we can make changes. So in the past year, we actually changed out our battery set, our entire battery pack. And we just had to redo our functional hazard analysis, and Transport Canada was willing to issue a new flight permit. So people talk a lot about flight simulation. This is our flight simulator. You see the little truck in the background, that's our beaching gear. It slides under the aircraft and you can strap the aircraft to that. Its typical usage is really to transport the aircraft from the ground into the water. But we can also tie it to the aircraft and run full simulations for our mission profile. So we were able to de-risk the first flight and subsequent flights by performing missions on the ground. So this could be practicing any of our potential failure conditions, or even just doing simple mission profiles from start to finish and pushing full power. And we can run any mission profile that the engineering team wanted to run. We could run on the ground in our flight simulator. And then, of course, at this time it was November, December in Vancouver. So when it rained, we stuck the nose inside the hangar. This was an empty hangar, no FOD. It was very clean. So we could just run the simulations this way as well. So we could run even when it was rainy out. So that led to our first flight. Since then, we're actually closing in on 100 flights with the aircraft. When we went to first flight, due to a variety of issues, but fundamentally, every single component that we received from our suppliers, every single supplier came in about 10% heavier. And so by the time we got to first flight, our calculation was that we would get an 8-minute flight. And so while the engineering team was very excited that we got to finish the proof of concept and show that electric aircraft could fly, we did not believe at the time that this would lead to commercialization. So after the first flight, we started doing some initial testing. We did a lot of cruise, range, climb, and takeoff. And surprisingly, I'll show you in a second, the performance improvement we got that led us to conclude that commercialization was on the horizon for us. The other thing that's really interesting about this, we get to do some testing whenever magniX, like the loss of power control situation that came up, we were able to do some simulations with this aircraft to determine whether we would continue to maintain level flight if we had a power loss. And so anytime, it's nice to have that experimental aspect of this is we can, if any of our suppliers, like the major component suppliers, like the engine or the batteries, want us to simulate something, we can do that in the real world environment. I just want to make this note because I've had a couple people say this. It is company data. This is not validation data that we're doing, because a lot of that, when we first put this together and calculated an 8-minute flight, I'm not going to spend thousands of dollars on flight instrumentation, to make sure I'm within 0.01% of the number when I'm not even sure I'm going to get to commercialization. So a lot of this we did as company data. They are calibrated instruments. It's just not at the same level as validation instrumentation. But we really wanted to gather company data for determination of viability. We weren't trying to get this product to certification anymore. We were trying to understand, was it worth it to pursue towards certification? We also have struggles here in Canada finding test pilots. There are only 5 delegated test pilots across Canada. We did find the one unicorn who actually had a float endorsement and lives in BC. That was amazing. We only found that about 2 years ago. But nobody really has any experience on this type of aircraft. And so we're using mostly our company test pilots. A lot of them have literally thousands of hours on the aircraft. And so when we're comparing to baseline aircraft, they're very good at giving us feedback on that. But that's all to say that the data that we got, the performance improvement was so vast that being 0.01% accurate didn't really matter to us in terms of being able to give a recommendation to our leadership team about moving forward. So anybody who's flown in a piston Beaver, it barely likes to keep its butt in the air. It flies along at 62% of maximum power is the minimum needed to keep it in the air at 5,600 pounds. And when we did the testing in cruise configuration, we found that the power for level flight for the eBeaver is actually only 41%. So this mattered both for the cruise portion of the flight, but also this is the settings you would use to calculate your reserve. So suddenly we went from an 8-minute flight to a 30-minute flight plus reserve. And now we're commercially viable. And this curve here, even though it's company data, was the one that convinced us to continue to move forward. This one's just fun because for anybody who's flown a Beaver as well at 5,600 pounds and it's warmer than 15 degrees out, it does not like to climb. I don't even know if it meets the Bach landing climb requirement of 3%, likely not. It wasn't a requirement for a B-car aircraft back then. But we are getting nearly double the required climb gradient at 80% power. We're getting 14% climb gradient with this thing. And that's because of the improvements in, reduction in drag primarily, and the improvement in the efficiency of the propeller. Noise is a big issue for us as well. Anybody who's working in an urban environment, I know a lot of you guys will probably be paying a lot of attention to this. You're probably a lot quieter than we are, even with the improvements we had. But for us, we've seen across the board approximately a 20 decibel reduction. We still get quite a bit of noise from the prop, but we've reduced the speed of the prop and we've reduced the diameter of the prop. So with the tip speed less, we are getting significantly less noise. We were able to test this also because we have an air operator certificate and we have our scheduled points. We were able to take the aircraft and test it out in a couple of different areas. We took it from Richmond over to Salt Spring to Victoria. We've taken it downtown, really to test it under those operational conditions. What does that look like? It really led to the charging infrastructure. It's one of my lessons learned. It's going to be a real problem. One thing that's also interesting with this aircraft, usually with an experimental aircraft, you have the right seat available for your flight test engineer. Unfortunately for us, as I said, all the components came in 10% heavier. There was one component that came in about 5 times larger and 5 times heavier than it should have been. And it ended up being the co-pilot. That was our battery management unit. So there was no room in the aircraft for any of our flight test engineers or essential crew to go on board. So every time we sent the aircraft out, we chased it with our Cessna 180. And so I have a short video here to show you. This is me hanging out of the Cessna 180 with the window open with a video camera so that we could take some footage of the aircraft flying, and it's Mount Baker in the background there. It's very windy. It's very hard to hold that thing steady while leaning out the window. All right, so from that, lessons learned, charging. Around the world, power source being carbon-free is going to be an issue for us in BC. 98% of our power from BC Hydro is hydroelectric, so we have a very clean power source, but not everybody's going to have that. The charging protocol standardization, I know there are groups working on this, but it is definitely going to be interesting. Like we're CCS1 here, Europe is CCS2. I knew Pipistrel sent aircraft over here because Canada has a program, and they sent it with their own proprietary charging protocol. Then they went to get an adapter for it, but I made an adapter that was CCS2, not CCS1. We also have Tesla's NACS, which is sort of taking over the world a little bit. It's hard to know exactly where to go. I know there are groups working on that. We had a distinct lack of power at our scheduled points. It was even hard just to get 220 volt power there. And the one interesting thing I think that I'm hoping that there's some work being done to correct this, but our first aircraft had a 540 volt system. And so it wasn't too bad. We had a small 7 kilowatt charger we could take with us in the 180. We could charge it into a 220 volt single phase plug and charge it. It took forever, but at least it would work. But when we did our battery upgrade recently, it went to 801 volts was the top voltage. And we discovered that almost every single small charger out there that can run on 220 volt single phase power tops out at 750 volts. So we're not able to get a complete charge on these small chargers now. We found potentially one that we're looking into, but this was one of the issues we had when we went to Oshkosh, was that we weren't going to be able to charge the aircraft on single phase power. We were going to have to find 3-phase. The nonlinear charge rates, that's something that's going to be very interesting for dispatch to manage, right? Like 40 to 80% is fairly linear, but above 80%, you start getting nonlinear. And so if they want to change how they dispatch the aircraft, if you want to go like a tour aircraft, probably only going to fly 15-minute flights, which means you can just keep charging it between 40 and 80. You have a set time it's going to take. But if you suddenly decide you want to dispatch that aircraft for a sched or a charter and it's going to go longer, now all of a sudden you might need another hour to charge it. That's something that the dispatch sides of the house are really going to have to understand better. Energy storage, I talk about this a lot, like just trying to draw off your energy providers is probably not going to work as we, so we're looking at like microgrid solutions and other potentials for us to be able to store some power at our locations. And then of course, additive heat. I think one of the biggest lessons learned for us out of operating this and charging it in different locations was that in order for this to be truly operational for our use case, it's going to need to be able to fly multiple times in a day, somewhere between 8 and 12 times in a day doing tours. The only way that's likely going to work is with a ground conditioning system because the heat is additive, right? At some point, I don't know that passive air is definitely not going to work. I'm not positive active air cooling will work. I think we're going to have to go liquid. It's something that our team is investigating. The other thing with thermal management that I want to make that I find really interesting is that there are temperature differentials. And I think that was a bit of a surprise to us, just how influential the environment actually was on the battery packs. So when we were charging in downtown Vancouver, it was about, I'd say about 12 degrees Celsius out, but the water temperature is really quite cold. And so when we set it up to charge on the water, the heat sink was so significant that we were getting an 8-degree temperature differential between the cell in the module that was in the belly, the cell at the bottom, and the cell at the top in the same module was 8 degrees Celsius temperature differential. And then of course there was a greater spread when you looked at the modules that were in the front or in the back. And if you are able to keep your battery pack all in one, I still think you're going to see temperature differentials from your outside modules to your inside modules. And it's not something I think that we spent a lot of time understanding. And again, I think that's going to have to be managed through that ground conditioning system. Also, battery cell module string balancing logic. We ran into some interesting issues there, mostly to do with battery suppliers don't understand operations. So they don't necessarily tell you everything that you need to know, and you don't even know the questions to ask. So that one can be interesting. Safety and training, aircraft operations on water. These are still questions we're trying to understand. I know the electric vehicle market, a lot of the vehicles will do submersion testing of their battery system, but I have yet to find any kind of specification that looks at the entire powertrain. What if your entire engine and battery system were submerged while it was energized? We're working with the NRC a bit to try and understand that better. And emergency response. One of the interesting things I saw when I was at one of the ASTM conferences, they had some automobile rescue charts, the ISO 17840. I think this would be something that'd be really good for us to develop for the electric aircraft market, so that when emergency response is approaching, they will have a quick reference sheet that shows them where's the high voltage lines, where are the batteries, where's the go and no go zones, and where's the best place to be hooking up the water to try and flood the system. Exactly, and design the access to the batteries to ensure the water, because if you're just spraying it on the outside of the aircraft, you're not necessarily getting into where the battery compartment is, where the cooling is desperately needed. So flight testing near term, this is what we're going to be doing over the next couple of months. We are going to do some more accurate validation to ensure, because we want to see if we can demonstrate the STOL. So we're going to do some position error correction, some STOL demonstration comparison to baseline, because a lot of the subpart B requirements are based on the STOL. So if we can prove that it didn't change, we might be able to make some claims of no change in some of those areas. We want to explore some of the behaviors at higher altitude. We know that the engine's being tested to 35,000 feet in the NEAT facility, but I don't know how much is being done on some of the battery work. We're going to do a campaign on wheels. This is interesting. We want to pull up some numbers just to find out what the performance improvement might be. Would we get an additional 15 minutes if it was on wheels? Because some people around the world, when we talk about commercialization, not everybody's going to want a float plane. So we are going to look at what the wheeled configuration of this would look like, because I think there are some people who just want an electric aircraft and don't care what type it is, but they'll likely want it on wheels. The question about the ventral fin, we're working on a DC to DC converter. This was then one of the issues on first flight. We had a DC to DC converter that knocked the high voltage down to power the low voltage system, but it had significant EMI and wiped out our radios. So we're looking at a new DC to DC converter. We're going to integrate it into the current aircraft and do some testing to see if we can make one work. And some propeller course pitch position optimization. We're finding we're getting a little bit of a blank out on descent. So we want to play with that a little bit more. So commercialization steps, we signed a letter of intent with magniX earlier this year to purchase 50 engines. We're trying to secure the supply chain. It's intended for our fleet, but also third-party operators. So interestingly, we've talked with some operators around the world. There's some people in New Zealand who operate in remote communities, don't always have access to fuel. They're interested in these sort of short hops. They're connecting islands similar to what we're doing. The other use case that's kind of interesting is in Europe. They have a lot of skydive operations, and their sport is under threat right now because it's recreational and it's burning gas. So they're looking for electric aircraft to help bring into their fleets so that they can show that they're trying to move towards a sustainable future to save their industry. Our initial STC target, we're hoping for 2026, but that's likely not our commercialization aircraft necessarily at the time. The commercial aircraft will likely be ready in 2027 because we'll probably have to upgrade the batteries. And we're continuing to sign LOIs with potential customers just so we can show that there is a market for this aircraft out there. And our expected performance of the commercial aircraft is anticipate a 60-minute mission with 2 to 3 passengers for first STC issuance, which would not be the commercial version, but 4 to 6 passengers for the subsequent iteration with the replacement batteries. We're trying to make sure the cockpit interface is as close to the original that the pilots are used to. Pilots aren't big on change, so try to make sure that we design is for as little change as necessary. So the throttle quadrant, although they'll lose the mixing lever, they'll still have 2 levers that are feel very much the same as they did before. It'll have a new screen, obviously, for the engine instrumentation, but a lot of the other stuff we're leaving the way it was. And we are going to make sure it has reversing capability. Our larger aircraft do have that right now, but the Beaver has traditionally never had reversing capabilities. We've been requested by our operator to include that. And I think that puts me at the end, and I'm ready for questions.
Well, that's just impressive. That's a whole lot of very, very interesting information. Thank you so very much. I'm going to go back to our recording. I digest 3 times minimum to be able to absorb everything you cover here. So without further ado, let me open the floor. And anybody has any questions, discussions?
I see a hand up, Yolenka.
Please do. Yeah. Hi.
Yeah, hi, Erika. Thanks so much for this. This is really great to see. I'm Yolenka Wolf. I'm Executive Director of CAMI, the Community Air Mobility Initiative. as many of you know, we work with states, provinces, and cities on the implementation of advanced air mobility. I had the pleasure of having Bert van der Stege, the CEO of Harbour Air, on a panel earlier this summer up in Whistler for the Pacific Northwest Economic Region. And I live on Bainbridge Island, so I'm also personally very, very excited about this. I'm just wondering if you can say a little bit about how you're looking at operations internationally, since you do currently have flights from Vancouver to Seattle. I think those are about a 1-hour flight, so potentially within the operational envelope of what's possible. And in particular, how if you've started to look at infrastructure issues like charging coming into Lake Union in Seattle.
We haven't, it's funny you should bring that up. We actually just had a conversation with magniX recently. We'd like to do a flight test down into Seattle. So that's something we're charting right now to test, is to, we'd have to fly likely from YVR to Anacortes, clear customs there. We think we could, just because we have to stay over water the whole way, we would then make a stop possibly in Everett, and then make it up into Lake Union. We're exploring right now the potential of charging. We believe that those locations likely have a decent amount of shore power available. Whether or not we can get the aircraft anywhere near that shore power is one of the things we're looking at. Locally, I've talked with, because BC Ferries is looking at doing electric vehicles. We have, there's High Sea has done the electric tug on the coast here as well. And so we communicate with them about, okay, how are we going to do and manage this infrastructure piece? When it comes from the flight to Seattle, the thing is, yes, it's a 1 hour, but it's actually an hour and a half, because you need an hour flight time and then the half-hour reserve. We're a bit short on that one right now. I've told our battery suppliers I'm really keen to get the 400 watt-hour per kilogram battery out there, because I think that extends the range on the Beaver significantly. But also with the 450 watt-hour per kilogram, we're now looking at like a Caravan or a single Otter and a flight for about an hour with a half-hour reserve, which would allow us to do that flight into Seattle. It's definitely on our radar. Because I know Lake Union, the noise complaints for the aircraft, same on Lake Washington. I mean, we get the same stuff up here. We get a lot of complaints about the noise. So we want to do a demonstration flight in the near term. This is something we're going to do in the next, hopefully 2 or 3 months, is do that demonstration flight so those people can hear the difference in the aircraft sound when it's coming in and taking off out of those locations, so that we can get more support from the local officials in Seattle and Washington State. So magniX is engaged with them, and that's definitely on our radar. But charging infrastructure is, we're working with not BC Hydro, but a couple of companies to try to put in 150 kilowatt chargers in downtown Vancouver and in Nanaimo to start. 150 kilowatt charger with the 200 amp service would allow us to charge in about half an hour. But it requires the minimum 600 volt service, 480 volt service in, depending on what charger you're using, 200 amp service. And there aren't, especially on docks, there isn't a lot of access to that, is what we're finding right now. And so that's why, we're a couple of years out from getting the aircraft to market, but that's why we're having those conversations about charging infrastructure now. So if there's other people interested in moving the charging infrastructure forward, we're pushing where we can on that one for sure.
Well, I'd love to stay in touch. You're probably aware that Washington State Ferries is looking at electrification of its fleet as well, which means establishing infrastructure at the current ferry terminals. I'm speaking at the Washington Public Ports Association meeting next month, or December, I guess, still October. I've spoken with them before. So I think, I'd love to stay in touch about that. I'm also part of the consulting team that's doing a 3-year roadmap for advanced air mobility in the state of Washington for WashDOT Aviation. So we're very much looking at those infrastructure charging questions, as well as operational routing. So anyway, thank you for this. I was really excited when I saw that you were today's presenter.
Fantastic. No, definitely. And I'll let you know when we're scheduling that flight into Seattle, and we can meet up then. That would be great.
Perfect. I'll be there.
Anybody else questions? Before anybody else raise their hand, I'm going to ask a question. Oh, I'm sorry, JP, you got some thoughts?
Yeah, so I was wondering actually, and thank you, Erika, for the wonderful presentation. I am working with a team developing hybrid electric propulsion system, and I was wondering if you considered hybrid electric propulsion system and your logic or reasons why you ended up choosing the all electric option at this stage at that level of aircraft and the mission profile.
Right, it's a good question. We have looked at the hybrid, and I think that our larger aircraft, we will likely, especially like the Twin Otter was going to require some kind of hybridization. But we were looking at the certification path, and we actually felt that the certification path to doing fully electric would be easier or faster than doing the hybrid. It came down to the cert program. Right now, if you're doing a hybrid, you've got two systems that are interacting that you've now got to deal with. Whereas if you just did fully electric first, we get that to certification, and now you understand that piece and you understand your combustion piece, and now you could hybrid the two together, or whatever process, whichever architecture you're looking at. It just felt from a cert perspective, changing as little as possible and minimizing the certification requirements was going to get us to cert faster.
So that's actually very interesting, because that's the first time I ever heard that, all electric certification path is going to be easier or faster than the hybrid path. And the logic and reasoning behind it is also very interesting. I was just wondering, is there any particular reason? I mean, so I understand the complexity side, but if the ICE engine, the internal combustion engine, is already certified by the FAA, does that make any differences, or is it still too complicated?
I think it's because like you've got to certify the electric engine anyway as part of your installation, and then on top of that you've got to certify the interaction between the two. When does each one, if you have a failure of this one, how do you manage this one? How the two interact? So now not only are you certifying the integration of the electric engine, but you're certifying the interaction with the original system. And so that to us felt like a longer certification path than just doing the fully electric.
Okay, I would love to discuss this with you more, especially if you are interested in talking to some people at the Ampere who had already got the initial the hybrid electric propulsion system certification basis approved by the FAA. And I believe
I've met both
who has done that.
I know Ed Lovelace and Susan Ying.
Oh, okay. So you
I've met with them a few times. Yeah.
All right. Good. Thank you.
This is Steve Tibbetts from Alpine Vertical. We changed our name from Ziva this year. My question, I'm in Tacoma, Washington, by the way. I'd love to get together at some point over coffee and
Absolutely.
see if we can collaborate. We're doing hybrid aircraft, as you can see in my screen behind, but it's a loosely coupled. We just use the electrics for vertical and then use the piston engine for cruise.
Okay.
The question was, and I've been following what you guys have been doing since the beginning. When you first took it out on the water, it sat really low in the water. The floats were like, I was afraid for you, right? And the question is, I know that the reality of the battery weight. And the question is, can you make a business at 2 or 3 passengers? That's the question.
No, that's why like what we're working with right now, the cell technology because we have to lock in our design, right? Like, as you know, you got to freeze your design so you can move it towards certification with Transport Canada or the FAA. The cell technology that we're using today is 240 watt hour per kilogram kind of numbers. And that'll get us the 2 to 3 passengers. And so we're moving to cert with that. But we know we have a supplier who's looking at 300, 350 watt hour per kilogram cells that have almost finished the testing phase. So they're looking like they're following about a year on. And with the 300, I think it comes out to 300 watt hour per kilogram at the aircraft level or the I'm not sure if it's pack level or aircraft level. But at that number, I'm able to put 4 to 6 passengers in, depending on what we have to do with for protections around thermal runaway, whatever, because I know they're still working on some of the means of compliance there. That is a useful business case for us. When we looked at the direct operating costs, we're on the Beaver. It's all about the batteries, and it's all about the cycle life of the batteries and how often you're going to have to replace the batteries and the cost of those batteries. And with the estimations we're getting right now, our direct operating costs are going to be almost exactly the same if we can put 5 people in it. Right. So then it's the same sort of operating cost, and hopefully that will go down. One of the things that I think we're shooting ourselves a little bit in the foot, because we're engineers and we're very conservative, but we're not giving any residual value to the batteries, right? We're saying, okay, we're going to run it from 100% state of health down to 80% state of health, and then you got to replace them. And we're considering that 100% replacement. But the reality is there's residual value in those batteries. They can either be used in a microgrid until they deplete down to 20%. And then you still got some residual value in the lithium that's inside, right? So we're being very conservative in some of those analyses right now. So in the worst case scenario, where I'm not taking any residual value in the batteries, I'm getting an equivalent DOC if I can put 5 people in it. So 2 to 3s, that's just to help us chart the cert path, and then we'll swap out the batteries, right? And after we've done that, as long as the batteries are meeting all the DO 160, DO whatever, or I don't know if they're going to use the ARP 7131 or which direction they're going to go exactly, but it should be relatively easy I'll call it easy, to change the batteries once we've marched the certification path at one point.
One of the things that we've done in our path to get where we're at is we design our own packs and battery management system. In doing that, I can't imagine having a BMS that takes up the entire co-pilot seat. So if you need help with that, just raise your hand and let me know.
That was one of those funny ones. It started out this big and 20 pounds, and then it became like 80 pounds and was like 4 feet tall. I remember when the thing got delivered, somebody had to drive, they had to pick it up and drive it overnight back because we were running out of time for the timelines we were trying to meet. And this thing arrived and we're like, I'm not even sure I can get this in the door. It was what it was is I think that most battery suppliers these days are making a battery management unit per string. And on that very first one, we did a battery management unit. They collected all the parts in one single box for all the strings.
Yep.
So instead of having 4 small boxes, we had one really large box. So that was 2019. Things have changed now. The new system we have in there now has 4 small battery management units instead placed throughout the aircraft. So we've actually put a seat back in. I didn't note it on our for our near-term flight testing, but one of the things we're really excited about is we put a seat back in there, and we're working with Transport Canada to allow essential crew to fly again. So we're actually going to get to fly in our airplane.
Okay, great.
They're excited about that.
Yes.
How many overall cells are you running? I know you mentioned the total kilowatt hours, but
yeah, it's a 158 kilowatt hour battery pack right now. And they're like 220 watt hour per kilogram kind of cells, something like that.
got it. Okay.
You're big.
Somewhere in there.
Thank you.
Thank you. Johnny, you only got about 5 minutes left before you're supposed to wrap it up. Are you done with Q&A, or did you have another question for me?
I have a question for you. From your early beginning of the baseline Beaver and estimated electrified Beaver flight time of 8 minutes to 30-minute flight, where do you guys attribute the changes? You mentioned the propeller, the probably a more modern propeller design, maybe a little bit lower little less tip loss. Is any of those benefit came from the significantly reduced the cooling drag and the profile?
It's the cooling, the cooling drag that we think was a big part of it. So an estimate done by Hartzell was that the propeller was about 15% more efficient than the one that we had on the baseline
that's
aircraft.
quite a bit. Yeah, okay.
But the rest, I mean, if you look at it with the big radial on it, how much of that is actually like blanking out the prop and it's just throwing air, the cooling air, through the engine? It's a huge piece. So to go down to that pointy nose and be able to use more of the thrust of the propeller, as I said, 300 pounds more thrust. again, company testing. We did some testing on the ground, and we're like, even though you're only still pulling 450 horsepower, we got 300 pounds more thrust out of it. So I think a huge amount of that is the cooling drag. We now just have this little thing under here.
Yep.
There's a scoop in the bottom for air over the radiator.
Yeah.
And the rest is there's a little gap around the nose cone that lets some air in around the engine. It's so significantly better. And I think it's a combination, you know, the parasitic drag, the cooling drag, and the efficiency of the prop. We haven't really tested to say how much each one is responsible for, but overall, it's a significant improvement.
Hey,
So
you got a useful result, so that's
I got a good, we knocked it out of, actually, we got really, you know, I think we got really lucky on that one. That's everything worked out as well as it did. I'm not sure we could get more of a performance improvement than we already got.
But it's also interesting, you mentioned about the another version with landing gear rather than the float. And in your estimation, how much drag benefit, I assume that's a reducing your drag if you have a nice wheel fairings and whatever. Do you have a rough estimate on how much reduction in the cruise drag between the float and the gear?
We haven't really done an estimate there. We're being very conservative. Again, I want to test it so that I know what those numbers are. We do know we get an extra 288 pounds of useful load. So we can either add more batteries to add more range, or that adds another person in. So there's a bit of a trade-off there. Right. But yeah, that's why we want to do the testing, is to see, because I think that we could probably achieve a 1 hour flight with and then have reserve on top of that with the Beaver if we were on wheels.
That's right. You know, Beaver had a wheel version, so
yeah, it's the
you don't need to reinvent it; just put it back on. Huh?
No, it can be another baseline version of the aircraft. So
that's fantastic. I mean, it's very interesting to see you guys are on a no nonsense path forward. I mean, everything you talk about, I can relate 100%. You know, the logical choice, the smart decision. I mean, it just.
I had an entertaining conversation with somebody from Joby. I was like, I'm eating 1 elephant. You're eating 5.
Yeah, absolutely, absolutely. That's a good analogy. Yeah, I like that. Actually, that's one of the reasons I think why we so gung-ho to invite you to talk, because I think your program is one smart example of some of the advancement can be made with smart decisions and logical decisions, and minimum resistant project path.
Yeah. The path of least resistance is our entire design philosophy. Yep.
I can absolutely relate to that, and congratulations to you and your team. It's making so much progress in a pretty short time. That's fantastic. Yeah.
Thank you, and thank you so much for having me here today.
And yeah, thank you for coming, and exceptional content. I mean, as I said, I'm going to go back several times and probably call you up sometimes to say, hey, what do you mean by this? Yeah.
Sure.
Fantastic presentation, excellent content, and thanks everyone for engaging and participating. I'll see you guys next time, and thank you, Erika.
Thank you.
Good to see everybody. Thanks, Johnny. Thank you, Erika.
Thank you.
Good presentation.